Hello, hello. This video is about HairNet. If you only care about HairNet, then skip to this timestamp. For my 66 subscribers, nice! If you've been wondering where I've been, I was basically dead for 2 months, and since then I've been learning calculus for a while, getting diagnosed with ADHD, learning Blender, and working on a project that has consumed all of my time. This project will probably be done in about 2 months, and then after that, I think that I'm going to make a string of shorter uploads because I don't like these massive projects. It's just too much time between uploading. So HairNet was originally made by this guy named Jandals on GitHub, and what it was for was to convert like proxy guides for hair into particle hair, which is Blender's old hair system. And I was trying to use it, and unfortunately it hasn't been maintained very well, so it wasn't working for me. And originally, I thought that I was just going to go in, fix a line of code, and call it a day. That is both fortunately and unfortunately for me not what happened. Instead, I've spent the past 2 weeks completely rewriting this plugin because the original code for it was a little bit messy. And also the level of functionality just wasn't quite there. Now, something that I didn't realize when I started working on this was that Blender does actually have a way to do something similar. And I kind of wish I'd known that, but I'm also a little bit happy that I didn't, because my solution is way, way better than Blender's default solution. But you can, in fact, do this conversion natively. It's just a little bit rough. So here we are in Blender, and this is what HairNet looks like. It is a little bit too feature heavy. I mean, I'm not upset. I went a little bit all out with it, way more than I needed to. And it just works by having like this group of curves here. And then there's this plane, which is going to be like our emitter object. And then we just say convert to hair particles. And now we've got a bunch of hair particles. So why in the world should you use HairNet over Blender's basic solution? Well, let me show you what Blender's basic solution is. So these are both curve objects. These are mesh objects here, all three of these. But this is a curve object. And if you wanted to get it to become particle hair, then you would have to convert it to a curves object. And then you would have to go, not even go into sculpt mode, you would come down here. And then you would have to find, now that this is the active object, you would have to find the object that you want it to be a particle system of, and then you would have to do that with both of them because they're separate objects. And then once you've done that, you can select both of them, and then you actually don't have to, you just select both of them, and then you go to sculpt mode, and then you come to curves, and you go to convert to particle system. Why is that in sculpt mode? I don't know, but it is in sculpt mode. And now they're particles, not these two objects. But on here, we can see that it has two new particle systems. Now, there are multiple issues with this. The first one is two different objects, two different particle systems. This is not ideal. What if we want them to be in the same particle system? There's no way that we can do that outside of joining them. But what if we don't want to join them? Well, there's nothing we can do. The second issue that we have is if you'll see, they only have two keys on them, which is not necessarily what you're going to want. And then also, they have definitely moved from where they started. These 2 points are not aligned. This point is definitely not aligned with this point in here. And if we go to the other particle system, we're going to see the same thing, where this point here is definitely not aligned with the tip of this point, and the root is so ungodly far away from where the root of this is. I didn't ask for my particles to move away from where the proxies were. Why is that happening? Well, it's automatically, when it converts, I think, connecting it to the mesh. You can disconnect hair and then connect hair, and it's automatically connecting them, and there's nothing that you can do to stop this as far as I can see, based on the default solution. So there are actually a lot of other reasons to use particle mesh as well, or sorry, to use HairNet as well. It lets you convert mesh, it lets you convert Sheetmesh, and it does it all automatically, and you don't have to think about a thing, and you've got 100 different settings to configure, and you can have all of your objects sitting in the same system. You can even add objects to the same system after you've already created the system. So if we go over to our basic use case, we have our hair emitting objects here. This is a Sheetmesh. The cool thing about this is you can mark seams on it, and then for every vertex along the seam, it will emit a fiber down along that edge loop. So if we select all of these and then we go to our emitter object, we have to select our emitter object last. It has to be the active object. You'll know that it is because across from hair source, it will say the name of your emitter object. And then we can convert them to hair particles, and voila, we have particles, and they stayed exactly where we wanted them, and they were all created perfectly. So moving along, we've got our Fibermesh examples. For Fibermesh, we want them to be one singular path. We don't want any forks here. We don't want any loops. We want 2 inverts, and we want a singular path in between it. Going to our curve example, it's much easier actually. So we don't want a cyclic curve, which is where the ends meet each other, but we do want just like this very standard curve. And actually it's way easier than with the mesh, because every time you extrude a vertex, it looks like it's going to be like problem geometry, but actually if you pull these apart, it's perfectly fine, and it's still just one connected path. And as far as I'm aware, there's nothing that you can do to undo that. When it comes to curves, there are different types of curves, different spline types. So we have a poly spline type, a NURB spline type, and a Bezier spline type. Now, I recommend working with Bezier for the purpose of HairNet. The nice thing about these is you can actually convert them from one type to another really easily. You just select the curve, you right click, and then you go to set spline type and you can set it to whatever you want. But the reason why I like Bezier for this is because you know for sure every single control point between them are going to be placed the number of hair keys that is equivalent to this resolution preview value. It's actually one less than the resolution preview value, but you'll know exactly what the conversion will look like because of that. By contrast, NURBS is like really weird, and I'll talk about this more at the end, but it's not clear how many hair keys are going to result from it necessarily. And then poly is fine, actually. It's just basically no different than the way a Fibermesh behaves. But I guess it has the combined benefit, I think, of retaining the same setting where like you can't mess up the geometry. So maybe you choose it for that purpose. All right, moving along, we have our Sheetmesh examples. So this is like a very basic example. We've got a marked seam up here, and what we would expect is that fibers will be made down the marked seam, and voila, they do. So the way that you mark seams in Blender is very simple. You go into edit mode, and then you select your edges, and then you right click, and you go to mark seam, if you've never done that before. So moving along to our Sheetmesh examples. So this is like what we're looking for. There's one marked seam along an edge, and we're not dealing with like any weird geometry. Now, HairNet can actually handle weird geometry like very, very well, but it's not perfect, and I don't want to like sell you guys a lie. So I'm not going to say that you like should deviate from like very standard quad geometry. You also shouldn't randomly mark seams. Like you can, and it will be fine, and I'll show you what that looks like in a bit. But generally speaking, I assume this probably isn't going to give you the results you want, but maybe it will. I don't know what you're going for. And then we also have just like some crazy topology as an example. And HairNet will work with all of these, so you can do them. I just don't know if like these are the results that you're looking for. Probably most people are just going to want to mark them like very typically. So here's an example of a situation which can result in an infinite loop. Now, HairNet's way of dealing with infinite loops is it has this max hair keys attribute, which I'll be talking about later. But if we very quickly convert these to particles, you can see the Sheetmesh hit the max key amount. And if we look here, I'll prove it to you later. But the number of hair keys here along this one fiber is going to be 300 because of the max hair keys amount. And it doesn't look like it, but I could actually just pull these out like for the next hour. It would take a very long time to get to the bottom of this stack. All right, so now here's like your very bargain variety use case for Sheetmesh, okay? I took like 2 minutes to go through and mark the edges of all of these. So they're all marked, they'll all make particles. And if we just convert to particles very quickly, it's gonna hang for just a slight bit, but now it's good. We can see like a very reasonable example of like how quickly you can get good results from this. I could even go into the particle settings a little bit more and maybe make it a little bit nicer on the clumping. And now it looks a little bit more natural, and we could add like roughness in there very easily, and we could get good results pretty quickly. So yeah, those are the Sheetmesh. Now we have our, okay, there's an object missing here. There's the object. All right, now we've got some particle system settings examples. So we've got 4 buttons here. The first one is active. All this means is that whatever particle system is highlighted in this area, if we had 3 particle systems selected, or sorry, if we had 3 particle systems on the object, whichever one's highlighted, that's the active system. And whatever proxies you have selected when you convert, those will go to the active system. So if we convert, we can see, in fact, the active system was added to. And just like that, just immediately done, don't gotta think about it. So for our next one, we've got a completely new particle system that we can make, and we can also like define the name for it if we want to. This is gonna be HairNet new. I'm gonna add some, okay, just to show you that it does do what I'm saying that it will do. We'll convert to hair particles. We can see that it is in fact a particle, and it is in fact on a new hair system. And it doesn't actually name the particle system, it names the particle system settings because, let's be real, that's like a way more important attribute. So for our next one, if I unhide this really quick, where did it go? How'd you get over there, my friend? All right, next up we have linking. So back here we've got a particle system, and on this particle system we have HairNet example settings. And so if we use the same HairNet example settings for this particle system that we're gonna make, it will have the exact same settings. And as a result of having the exact same settings, we can see that whenever we change something on one of these settings, it will change them on the other one as well, because both of these particle systems share their settings. Now, if you don't want that to happen, you can come over here to copy, and we can use the same HairNet example, and we can say HairNet new will be our new settings. I think I already have this, so it's going to rename it to like an appended amount, but same thing. So we've converted it, and as we can see, it is the same settings, except they're not linked. So I can change this one, and it won't change the other ones. So that's the difference between link and copy. They do basically the same thing, except the incredibly important ways that they do something different.
Well said.
So we've got our config mode up next. Actually, I didn't even put this in the example, but something else we can do is we can link proxies to a collection. By default, it will link, it will link them to a collection called HairNet proxies. So I'll just show that off real quick. If I convert to particles with these, and we come down, I actually am in config mode right now. If we actually convert and we're not in configuration mode, then it will hide these particles down in a new collection, or it will add them to this already existing collection. And you can name this collection whatever you want to name it. It doesn't matter, but that's just what it defaults to. So configuration mode is a way if you have like a ton of shit going on in your scene and you don't want to wait for like all of the particles to process before you find out if your stuff is okay. You can switch on configuration mode. You can convert to hair particles. It will make a new particle system, but that's easy enough to get rid of. And it will show you in the info box. You can go to the info box by going to the top left of any area, and you can switch it between all of the areas, and under scripting at the very bottom, there's this info button. It will display to you exactly what it's going to do. So it'll say that it's going to use a new particle system with copied particle settings, and it's got the name of the new system. And then it'll also say what Fibermesh are going to convert, what curves are going to convert, and what sheets are going to convert. Now, if I selected a bunch of lights, and then I clicked on this, then it would tell me that the lights are invalid, and so we can't convert anything and no valid proxy objects were selected. This will also apply to situations where Sheetmesh is invalid. You'll be told ahead of time if like your Sheetmesh doesn't have any seams that are marked. For example, if I just clear these seams real quick, and then I click on this and I click on the hair, it tells you that it has faces but no seams and no valid proxy objects are selected. The other thing that I've been doing this entire time, as a matter of fact, is this hide proxies button. So if this is on, then it will automatically hide the proxies after it is converted, so we can't see the proxies anymore. You can also turn this off and the proxies will stay unhidden. So next up, we've got max hair keys. We are back to our original infinite looping example. So we've got some infinite looping geometry. We don't want this, obviously, but we happen to have this, and this is just a way for Blender to not crash. So if we click on this and we click on here and we set our max hair keys to 1,000, if we convert, now we can see this time, it did in fact make the particles, and it will tell you down here that it hit the max key amount. and I'm going to prove to you that it hit the max key amount. I wrote this script to tell me what the longest particle of any given object is. I'm going to run this script, and if I go over to the console, we can see down here that the longest particle does in fact have 1,000 hair keys. We've got root snap mode. So this is very, very, very useful and something I implemented at the end because I realized how important it was. What this will do is when you convert to hair particles, it will make sure that the roots of all of the particles are snapped to where the hair emitter is. And the reason that this is useful is because for determining children, what children belong to what particle is dependent on the root's position relative to the mesh. So you might have seen some like weird examples, like even in the Sheetmesh example right back here, like what is happening here, right? And this looks so funky because the children aren't calculated the way that the particles are calculated. It is relative to the root's position to the mesh of the hair emitter object. And I can prove this to you. If I say select roots, we can see all of the particles, their roots were placed where they were supposed to be placed. And all of their particles, if I select linked on this, they follow along the seams just like they're supposed to. But the children don't follow that logic as well, which is why we sometimes need this root snap mode, which only moves the root hair key, unlike Blender's default curves implementation. Whenever it tries to connect the hair, it will just move the entire particle, which if you've delicately placed all of your proxies, as I have on the project that I'm working on, that kind of sucks. So HairNet actually has 3 ways of determining which side of the particle is determined to be the root. The highest priority mode is root select mode. And the way root select mode works is very simple. It's just what if the vertex or the control point on the end of the curve is selected and the opposite end isn't also selected, then that's the end that HairNet will use. And you should be a little bit careful with this because if you have both ends selected, then it will default to whichever one it finds first. So make sure you only select one end. It doesn't matter if you select these interior vertices, it just won't have any effect. And if I select these and root select mode is enabled, I guess root snap mode will show this off, and then I convert to hair particles and I get rid of the children. As we can see, the particles that I selected up here are now down here because root snap mode is on. And then this one, which I selected right here, is now down here, whereas this stayed up here. I hope that all of the this and the there and the were and the what made sense. But basically the ones that I had selected got snapped to the mesh because that's what they're supposed to do. The second highest priority way HairNet determines where the root is going to be this root locator. So I have a sphere up here. This is the sphere object. And you would think, based upon, okay, so HairNet's default way of determining where the root is just the center of the geometry of the hair source. And that's like what it will determine in terms of root placement. So whichever end of these particles is closer to the center of this plane, that's what it's going to use by default. And I can even show you that very quickly, even though it's been happening up until now. If I exit out this sphere, and I select this and I convert to hair particles, it is decided that the other side is more important because I left root select mode on. But if I convert to hair particles properly, then it will just default to the side that is closest to the object, which makes sense. But if I undo that and I put sphere in for the mode and I turn off root select mode again, and I've got my basic setup and I convert to hair particles, the ends closer to the sphere is what it will determine as being the roots for the particles. Now, unlike with the hair source object, the hair source object is based on the average of the vertices, basically. But the root locator object, this is going to be based on wherever the locator is at for the object itself. So if I bring the mesh down here, this isn't going to have any effect. And if I leave the sphere selected in here, then we're still going to get the same exact result because it's based on where the transform is. The transform is still up here, so that's where it's going to go. Whereas for the hair source, because I know that like a lot of people with their rigs, their transforms, maybe wherever their transforms are, it's going to be based on the average of the geometry. All right, so now our final parameter is curve resolution. The thing about curve resolution is that it doesn't behave the way that you would necessarily expect it to behave, unfortunately. So I'm going to start by setting this parameter to 0. And on each of these curves, we've got a Bezier, we've got a NURBS, and we have a poly. I want you to think about what you would expect to happen when HairMesh converts these. All of the settings on these, the resolution preview U is set to 12. So if I convert these very quickly, we can see that the poly has 1 point for each of its control points. And then the NURBS, for some reason, has 11 points in between its outside control points. And then the Bezier will have 11 between each control point. Now, it really is weird because in contrast to what you may expect, now it is really weird because in contrast to what you may expect, all of these curves have 4 control points. So the poly obviously is 4, that's very clear. And we got 1 hair key for each control point. The NURBS has 4, but then it acts like it only has 2 control points when we convert it. And then the Bezier has 4, and then it's got 11 hair keys between each control point, which makes perfect sense to me. But if I extrude the NURBS some more, now it's got another 3 control points, and I convert it again, just the NURBS this time. And we look at how many particle keys it has. It looks like it added 11 for each new control point we added. I'm not sure why the functionality is like this. I don't actually understand how it's working behind the scenes, so I recommend that you stick with either poly or Bezier curves, generally speaking, but you do you. So the way this curve resolution works is if it's set to 0, then it will just use whatever the individual curve objects are using. However, if it's set higher than 0, then it will apply this curve resolution amount to all of them. So if I get rid of this particle system again and I convert all of them again, as you might expect, it's going to be a lot of hair keys. Definitely going to be a lot of hair keys on all of these, except for the poly, because the poly it has no effect on. And then if we go back and we set this to something like, 1, and then we convert again, they're all poly curves now. Congratulations. So that's how that works. The only other thing that I would say about this is if you want to know what these curves will look like when they are hair keys before you actually convert, the easiest way to do that is just to convert them to mesh and see how many vertices they have. And however many vertices they have, that's how many hair keys they'll have, because HairNet is just converting them to a mesh and then converting them into particle keys in the end. And that is HairNet. If you are the type of person who prefers to read things, I have an autistically, thoroughly written README that goes over even more than what I've talked to you about in this video. And I've got a coffee link in the description if you appreciate me for making this. And if you want to see why I made this entire plugin in the first place and killed myself for 2 weeks to make it so beautiful, then subscribe to my YouTube channel and stand by for the video on that. Bye.